Morning, we are factoring some more today. We are focusing on trinomials, meaning a polynomial with three terms. The prefix tri means three. Think tricycle has three wheels. So trinomials, ax squared plus bx plus c. We have this fancy x method that we can use to help us factor these trinomials. And we focus on our coefficients and constants in this x method. So whatever my a and c terms are, I multiply them together, and that's the number that goes in the top of my x. Then b, the coefficient on my middle term, goes in the bottom. So then I look at my product of a and c and my b values, and I think, okay, what are two numbers that multiply to the value in the top and add to the number in the bottom? And that is how I find m and n. So once I have filled in all of the boxes in my x, I can write my trinomial as the product of x plus m times x plus n. And this is easier when a is 1, so we'll practice with that first. And this should be a lot of review for you. But x squared plus 7x plus 10. A is 1, c is 10. 1 times 10 is 10. My b value is 7. So there are my top and bottom numbers, and now I need to find two values that multiply to 10 and add to 7. Well, those numbers are 5 and 2. So my factors are x plus 5 times x plus 2. And I can check that I have factored correctly by FOILing and making sure I get the trinomial I started with. Okay, let's practice this again. X squared plus 3x minus 28. A is 1, c is negative 28. 1 times negative 28 is negative 28. My b value is 3. So I need two numbers that multiply to negative 28 and add to 3. That is 7 and negative 4. So x plus 7 times x minus 4 are my two factors. Again, FOIL to make sure you get the correct outcome. Now, what do I do when a is not 1, if it's bigger than 1? We are going to follow the same steps most of the way through, and then at the end, I'm going to divide my m and n values by a. So let's see that in action. 5x squared plus 29x plus 20. 5 times 20 is 100, and my b value is 29. So two numbers that multiply to 100 and add to 29 are 4 and 25. So now that I've found those values, I need to divide by a, which is 5. So that's 4/5, and 25 over 5 actually reduces to a whole number. So my two factors are going to be x plus 5 times x plus 4 over 5. Now the last thing I need to do is clear this fraction, 4/5. I clear that fraction by multiplying by the denominator, which is 5, and I only multiply the values in this parentheses. So the x and the 4/5. So that's going to become 5x plus 4. Again, my first parentheses doesn't change, and you can check to make sure you've done this correctly by FOILing and get the trinomial you started with. All right, let's practice that again. 2 times 6 is 12. My b value is 13. Numbers that multiply to 12 and add to 13 are 1 and 12. So I need to divide both of those by a, which is 2. So 1/2 does not reduce, but 12 over 2, it becomes 6. So I have x plus 6 times x plus 1/2. To clear that fraction, I multiply by denominator, which is 2, on the x and the 1/2. So x plus 6 stays the same, and that's times 2x plus 1. All right, 3x squared plus x minus 2. A times c is negative 6. My b value is 1. Numbers that multiply to negative 6 and add to 1 are negative 2 and 3. Divide both of those by 3. This becomes 1. So I have x plus 1 times x minus 2/3. To get rid of that fraction, I'm going to multiply x and my fraction by 3. So x plus 1 stays the same, and I have 3x minus 2. Okay, last one for this page. 2 times 7 is 14. My b value is negative 9. Numbers that multiply to 14 and add to negative 9 are negative 7 and negative 2. Divide both of those by 2. This becomes negative 1. So x minus 1 times x minus 7 over 2. Multiply both parts in here by my denominator of 2, and it becomes 2x minus 7. Okay, so again, this is all stuff that you have reviewed in geometry and you learned originally in Algebra 1. So now that we've refreshed those memory cells, we've dusted off the cobwebs, got the gears turning. Let's talk about something that looks a little new to you. That is the difference of two squares. If I have two perfect squares being subtracted from each other, that factors out into the square root of the first term. I apologize for that interruption. A squared minus b squared. If I have two perfect squares, a and b, whatever the square root of those terms are, that factors out into a minus b times a plus b. So the best way to recognize if you have difference of squares is to start by memorizing your perfect squares. So a lot of these you should already know, but some of the bigger ones like past 12 might be new to you. So the key with this is recognizing that you have perfect squares to begin with. Then you identify your a and b terms, so the square root of your first term, the square root of your second term, and then you can factor. So let's start with this first example, 25 minus 36x squared. The square root of 25 is 5, so that's going to be my a. The square root of 36x squared is 6x, so that's going to be my b. So when I factor this, it's going to be a minus b times a plus b. So 5 minus 6x times 5 plus 6x. And again, if I FOIL, if I do first, that's going to be 25 outer, negative 30x inner, plus 30x. And the final one is negative 36x squared. What happens with my middle terms is they cancel. And that is why in our difference of squares, even though we're FOILing the two binomials, we don't have a middle term like we do in a trinomial because the middle term cancels. All right, let's practice again. 49x squared minus 64. My a, square root of 49x squared is 7x. My b, the square root of 64 is 8. So a minus b times a plus b. On to the next one, 36a squared minus 25b squared. Square root of 36a squared is going to be 6a. Square root of 25b squared is going to be 5b. So 6a minus 5b times 6a plus 5b. 4x squared minus 121y squared. A is going to be 2x. B is going to be 11y. A plus b, a minus b, or the other way around. The order doesn't matter. 144y to the fourth. A is going to be 12y squared because I have y to the fourth. And b is 11x. A minus b times a plus b. And lastly, this one might look tricky, but don't let it fool you. This is being squared, this is being squared, which makes them perfect squares. So a is actually 3x minus 1, and b is x plus 6. So I'm going to have a minus b, make sure you're protecting it with parentheses, times a plus b. So I'm going to distribute that negative here, and I'm going to get negative x minus 6. And now I can combine my like terms, and I'm going to end up with 2x minus 7 times 4x plus 5. And again, with all of these, you can FOIL back out to make sure that you're getting the correct factorization. And that is a wrap on today's notes. So memorizing these perfect squares is the key to recognizing when you have a difference of two squares.